Okay, so we are continuing. We got to talking about normal distribution, probability underneath it, a normal distribution curve. The total probability is 1 for any distribution. The area underneath is 1 as a percent, 100% probability. We talked about z-scores, okay, and we looked at a z-score table. But really, that's the only time. We're not going to give you a z-score table anymore. That's just for you to be aware. You're going to use your calculator. Calculator has all the values saved. More decimal places as well. So then, we are starting to calculate with our calculator. The directions are in your notes, how to do that. But we're going to go through it together. We started with the first one, but we didn't quite finish. So, it says find the probability or area under the curve for each z-score interval. Give the area as a decimal to the nearest hundredth and a percent to the nearest whole percent. So we want the probability that the z-score is less than 1.78. So in terms of work for a question, you just do a little normal distribution. All good back there? Okay, so normal distribution, positive z-score is going to be to the right of 0. Okay, and we want to find that probability. So that means we're using our distribution in our calculator. So I'm just going to clear this. Well, actually, it was still there, but I'm going to clear it. So where do we find it? At second bars, which is distribution. That didn't, just a second. Second bars. Distribution. Guys, what's going on? Settle it. Okay, so here, normal CDF. We only use normal CDF and inverse norm. So normal CDF, if we want to find that area, that probability underneath. So cursor down or select 2, enter on that. Okay, it will, sometimes as a default setting, put in -1 e to the 99 means in scientific notation, -1 times 10 to the 99. So it's -1 with 99 zeros in the negative direction, right? So it's the smallest value that the calculator can hold. So that goes way out here. So it makes sure it gets all the values. It'll still give you the same value for other other small negatives, but just to be safe, we want to just put in the smallest that your calculator will hold. So cursor, oops, that's the wrong thing to press. Enter there, and then your upper boundary is 1.78. Okay, so if we're given z-scores, then we're using 0 and 1. If we're given the mean and the standard deviation, we use those. But we're only given z-scores. So 0, 1, so you go down to paste. When you do that, it shows like that. Okay, the n is cut off there. If you have an older calculator, then that's how you would enter everything. You do normal CDF, and you would open a bracket, put the lowest, the highest, 0 and 1 with commas in between. Okay, so if you have an older calculator, that's what you would end up doing anyway. And that's what you will show on your paper. Okay, so off there. So I'm going to go, okay, so the probability equals normal CDF. My computer's acting up. Then -1 times 10 to the 99. Or you can put E. I put in scientific notation, but that's messy because, I don't know, something's wrong today, as it often is with this thing. 1.78, 0, 1. I'm writing really big, but that's what you would write down. So then on my calculator, I enter, and it gives me the value. It says as a probability to 2 decimal places, so 0.96. and then as a percent would be 96%. So equals 0.96 or 96%. Okay. Whoa. Okay. Next one is probability greater than 1.61. So that's going to be this area here. Okay, so this is 1.61. Get your calculator out. Clear that. Second, bars. Sorry, it's not registering. Okay, so second, bars, and then normal distribution, normal CDF. So now our smallest value is 1.61. Enter on that, and then our highest value is infinity, positive infinity. In our calculator, we go 1, and then that fast way is second, comma, which gives you the E, 99. Okay, mean, standard deviation, we're using z-scores, paste it. Okay, 0.05. Okay, so 0.05, 5%. So I'm going to put it up here. Next one, negative 1.83. So negative to positive 2.65. Okay, you're trying to find that area. So, second, distribution, normal distribution, CDF, and then, what was that again? Negative 1.83 to 2.65. So, negative 1.83 to 2.65. 0.96. And then 1.83, 2.65 there. Okay, the nice thing in your calculator, it will keep. So here, the only thing, what you could actually go up and go up to your normal CDF, enter on it, and then just go back, because the only thing different is that it's from 1.83, so delete the negative. Okay. Oh, deleted too much. So insert 1. There we go. And then just enter on that. Okay. So you can do a few little shortcuts in your calculator. That would be 0.03 or 3%. I'll just put it here. Okay. So that was using normal CDF. That's what you want to use when you're trying to figure out the probability, or the percent, probability as a percent, or the area under the curve. Now we're given the percent, or probability, and we want to figure out what the z-score is. Okay, so for each of the following, find the z-score intervals to the nearest hundredth, which represent the area or percent given. Okay. Just listen, you can ask questions anytime, but mumbling does not help. Okay, so we're going to use then inverse norm. So when we get out our calculator, we go to second bars, and then the one right underneath, what we've been using is inverse norm. Okay, most of the newer calculators prompt you. If you have an older calculator, I'll show you what to do in a sec. The area underneath, you always do it as a decimal. So if that's a percent, move the decimal 2 to the left, divide by 100, so 0.1762. 0.1762. Enter on that. We're trying to find z-scores, not data values. If we're trying to find data values, we need the mean and the standard deviation. We don't know, so we're doing z-scores, so 0 and 1. And you'll notice here, newer versions have this. Older versions don't. So if you have an older version of the calculator, you might have to do a little bit of math. But in this case, it's asking you, is that 17.62% on the left of that normal distribution, on the right, or in the center? Symmetrical in the center. So in this case, it's from the left. So if it's going from negative infinity to some z-score and giving you that percentage, that would be the left tail of the graph. Okay, so I'm going to keep it on left there. Okay, so in older versions of the calculator, it always assumes it's left. So it's really not going to be any different in this case. So we enter on that, and then I guess cursor down, sorry, paste. And this is what older versions of the calculator, close to what they look like. You wouldn't have this left there. Okay, so you would have here, our z-score is going to equal, I don't know what happened over the weekend. So z equals inverse inverse norm Okay, so your percent as a decimal, 0, 1, and I will put in the left, but if you have an older version of the calculator, you would just close your bracket after the 1. Okay, so enter on that. So it should be a negative z-score, okay, and it is. And we'll go to, what did we say to round to? Near 7. So negative 0.93. It is not a percent, it's a z-score. Remember, it's telling you how many standard deviations is below the mean. Okay, so really our diagram probably should have been a little bit more to the right, okay, in terms of scale. Now, the next one is on the right, so the right tail of it. So, in this case, you could actually go in and copy this, but because of that, I'm not going to, because of it being on the right instead of the left, I'm going to just redo it, just say some of it anyway. Okay, so now our percent is 14.92, so 0.1492, 0, 1, and cursor to the right. Okay, it's the right tail. Cursor down, paste, okay, and so that gives you a positive z-score of 1.04. So I'm going to just write it right there. And this was negative 0.93. Okay, so the thing is, who has an older version of the calculator? Okay, so here's what we'll need to do. Older versions of the calculator, take the percent going from the left. So what you need to do is go, okay, 100% minus 14.92 is this. Okay, so 100 minus 14.92, and this is going to be 85.08. Okay, so that percent. So in yours, you're going to do inverse norm. Yeah. And then you'll use that as your area, 0.8508, comma 0, comma 1. And when you do that, so here second distribution 3, so 0.8508, 0, 1. So it will look like this. That's what you'll need to do. You won't have the left. You'll have inverse norm. You fill in bracket 0.8508, 0, 1. You won't have the left because you don't have that feature. Okay, and you'll get 1.039, which is the same answer, right? 1.04. Okay, so you have to do that one extra step. You have to realize that your calculator is going from the left. You don't have the choice of going on the right. Okay. All right, so then the next one, remember this is the mean, so that's 0 there, and we want to find the z-score. So we know right away that the left boundary of that is 0. Don't need a calculator for that. But we do need to know what the z-score here is. So this would be, you're not going to use the middle if you have the newer version because it's not symmetrical. Okay, so it's not 25. It assumes if you're using a middle that the 25.80% or 0.2580 probability is symmetrical about the middle, but this part here, remember, is higher than this. So we can't use the middle feature, okay, no matter which version of the calculator you have. So what you can do, no matter which calculator, is remember this is 50% or 0.5. So we're going to put in our calculator 0.7580 as our probability from the left. So this was down here. This is going to be inverse norm 0.7580. Okay, so do that in your calculator. If you have a newer version, you're doing from the left. If you have an older version, that's what you're doing. So it's the same either way. Okay, and so 0.70. And that's your z-score. Okay. All right, and then the last one. So what do you do here? Again, you can't use middle, okay, because it's not symmetrical. And you have to find both of these. So in a way, you could use middle if you wanted to. You could draw the same on each side. So this over here, double that up to use middle. But I wouldn't bother. I would think about, okay, add these together, gives you the total here. Subtract from 0.5, and that will give you this area, right? And then you can find this z-score. 0.5 minus this area gives you this z-score, and then subtract them. Or not, well, you don't subtract the z-scores, sorry. You subtract the areas, and then you can get those z-scores, right? So I'm going to just do this on the side because it's just easier than the smartboard right now. Okay, so this 0.2145, this
0.1293. So this area will be 1 minus 0.2145 plus 0.1293. So, okay, so 1 minus, I'll just do it together. You can add them together or do it in brackets. Oh, sorry, not 1 minus, but 0.5 minus. Sorry, let's go back up here. Because it's just half, right? Half of the normal distribution. There we go. Okay, so here 0.5. So 0.1562.
Guys, are you good?
Quiet. Peace. So that's 0.1562. Then normal distribution. So now we're doing inverse norm again. Oops. Okay. Area is 0.1562. 0.1 from the left. Okay, is negative, so here, so Z equals, we'll call that Z1, inverse norm, 0.1562, 0.1 left. Negative 1.01. Okay. Then this one here, so that's Z2, will be inverse norm of 0.5 minus 0.1293. Right, so 0.5 minus 0.1293. And you can actually do that within your calculator, but we're going to want to see what the value is. So I wouldn't do it within the calculator unless you're just doing it for practice. You work on a test, so on Wednesday, I need to see what you're doing here. Okay? So you don't just give the answer. If it's a written response, you show inverse norm from norm CDF and what values you're putting in. Okay. So 0.370701. If you don't have that left feature, you don't have to put that in your work. Okay, negative 0.33. Okay, so Z1, Z2. Okay, so I guess I should do this for the video. Okay, so
that's the end of what was scheduled for Friday. Now we're going to look at the next set of notes. So that's practice. Okay, so you're going to do that on your own in a bit.